So, following JEE paper. So, what is the first question? From 10th question, the topic starts. So, first question is: a telescope has an objective of focal length 100 centimeter and an eyepiece of focal length 5 centimeter. What is the magnifying power of the telescope when the image is formed at the least distance of distinct vision? See, for telescope, when final image is at infinity, there is normal adjustment. Magnification is FO by FE. But if the final image is at near point, that is distance of distinct vision, D is approximately 25 centimeter. Magnification value is FO into FE, FO by FE into 1 plus FE by D. This is the value. This is the formula for that. You can note it down. So this will be equal to FO is 100, 100 by 5, 100 by 5 is 20. 1 plus FE is 5, 5 by 25. 1 is 5 is 5 plus 1 6. So 20 into 6 by 5. 5 1 is 5, 4 is 6, 4 is 24. So it is 24. Now we have a compound microscope. A compound microscope has an eyepiece of focal length 10 centimeter and an objective of focal length 4 centimeter. Calculate the magnification if an object is kept at a distance of 5 centimeter from the objective. So that the final image is formed at the least distance vision, and it is given to be 20, not 25. Okay, they have mentioned in the question 20 centimeter. So we will take 20 centimeter as D, capital D, near point. So magnification they are asking. So what is the formula? So magnification will be, total magnification will be magnification due to objective into magnification due to eyepiece. And magnification due to objective is VO by UO. Because it is kept at 5 centimeter. Its focal length is there, we will get its image distance. And due to eyepiece, it will be, because it is formed at a near point, magnification is 1 plus D by F. FE. Right. This is microscope. So D we know, FE we know, UO also we know, VO we don't know. So how to get mirror formula you can use 1 by F is equal to 1 by V minus 1 by U. So 1 by F is how much? For objective it is 10 by VO minus 1 by, this is minus 5. So plus 5. So VO becomes 1 by VO is equal to 1 by 10 minus 1 by 5, which is 1 by 5 to take common, 1 by 2 minus 1. Minus 1 by 2, so minus 1 by 10. So VO is minus 10. So this 10 by this 5 into 1 plus 20 by FE is 4. FE is 4. Oh, sorry. Objective focal length is 4 and eyepiece focal length is 10. So this will be 4 actually. So this will be 4. 5 minus 4 is 1. 1 by 20. So VO will be 20 actually, plus 20. So this will be 20 by 5 into 1 plus D is 20, FE is 10. So it is 5 is a 4 is a 5 1 is a 5 4 is a 4 into, and here we have 20 by 10, that is 2, 2 plus 1 3. So 4 3 is a 12. It is option A. I want to say option. Go ahead. So 12th question. A microscope is focused on a mark on a piece of paper. So, and then a slab of glass of thickness 3 centimeter and refractive index 1.5 centimeters placed over the mark. How should the microscope be moved to get the mark in focus again? So, basically, you have to make U same, then V will be same. So it will come into focus again. Correct? So how to make U same? Because when you keep a slab on the mark, so initially microscope was getting some U. Now U will not be same because of refraction. There is bending of light. So we have to use apparent depth concept here. So for the lens, even though the rays come from here only, for the lens it appears that it is going from denser to rarer. Denser to rarer, a ray bends. Uh, the ray will go like this. Denser to rarer, it bends away from the normal. So it looks to the microscope as if the ray is coming from here. So for the microscope, this will be U, and this will be object. So this will be U. So V will be accordingly there. But we want U to be same, so that V will be same, so that we will again focus it on the screen. So by that much amount, you have to take it up or down. So here, if you see, to increase U, because U is decreasing because of the slab, you have to make U again the same value as it was in first case. So you have to take the microscope up only. Then if you take it up, then you will again become same. Means you will be again as its value as in first case, right? So how to get that? So by how much amount this raises? Suppose this is a slab, and okay, sorry, and suppose this is the mark here. So by how much amount it goes up, by that much amount microscope also should be taken up. So now how to do this? Apparent depth is this, real depth is this. So real depth minus apparent depth is your answer. So apparent depth is real depth by mu, and real depth is 3. 3 by thickness of the slab. 3 by 1.5, which is 2. So apparent depth is how much? 2 centimeter. So this is 2 centimeter, but you want this value, that is 3 is real depth. 3 minus 2 is 1 centimeter. So by 1 centimeter, the image is raised. The spot is, the mark is raised by 1 centimeter. So you have to take the microscope upward by 1 centimeter. 13th question. What causes chromatic aberration? So, chromatic aberration means uh, in the image, suppose there is a lens, there is an object here. So in the image, we see some color distortion will be there. Why this happens? Because variation of focal length of lens with color. Because 1 by f is equal to mu minus 1, mu 2 minus mu 2 1 minus 1 into 1 by r1 minus 1 by r2. So for different colors, actually lambda mu refractive index depends on the wavelength of the light also. Different wavelengths will have different refractive indices. It's a different power of getting refracted. So if mu changes according to color, F also changes. If F changes, a parallel ray will bend them to different extent. So here some color, here some color. White light is coming, but some different colors are coming. Some color distortion is there. So that is due to variation of focal length of lens with color. And 14th one. The man's near point is 0.5. Sorry. So the man's near point is 0.5 meter. So that is man actually. This is the near point. This is the far point. Power of the spectacles lenses required for reading purpose. So reading purpose means near point This is 0.5 meter to centimeter. If you convert it is almost to 50 centimeters. Right? But near point we know it is for average means 25 centimeters. So for reading purpose means we have to make his 50 centimeter near point as 25 centimeter. And for seeing distant objects means far point is 3 centimeter. We have to make it to infinity. So how to do this? Now we will first reading purpose we'll see. So for reading purpose, so if the object is at 25 cent, see he can see. Suppose this is your eye. Suppose this is your eye. So he can see from 50 centimeter till 3 meter. So in this range he can see. His eye lens can see. So if something is there at 25 centimeter, what we have to do? Somehow we have to make its image. We have to get its image. We have to use some instrument here, such that this instrument will make the image of this 25 centimeter, the object at 25 centimeter. Its image should be formed at 50 centimeter, and this image of this lens will become object for eye lens, and eye lens can see a object is at 50 centimeter. So you have to use an instrument for which if u is equal to minus 25 centimeter, v should be minus 50 centimeter. So that focal length you have to use. So 1 by v minus 1 by v. So 1 by v is minus 50 by 1 by this is minus 25. So 1 by 25 minus 1 by 50 you will get. 1 by 25 to take common, 1 minus 1 by 2, that becomes 1 by 2. So 1 by 50 you will get. So f is, okay, this is in centimeter. They have asked power, p is equal to 1 by f, so this becomes power. This is in centimeter, in meter we want. So it will be plus 2 diopter. So for first case it is plus 2 diopter. So this or this. Right. So second case we will see distant objects, distant objects. So if some object is there at infinity, for you to see it, what should happen? You should use some optical instrument, some lens, such that it will make its image at 3 meter. So when it is at 3 meter, the image of the lens is object for your eyes, and your eyes can see a object is at 3 meter. So you have to use such a lens for which if u is equal to infinity, v should be minus 3 meter. So how what should be its f? 1 by f is equal to 1 by v minus 1 by u. So u is infinity. This will go off. So v is minus 3. So f is okay. 1 by f is 1 by minus 3 meter per meter. That is diopter only. So power is minus 0.33 diopter, which is option C. 14 is C. Then 15th question. A piece of plain glass is placed on a word with letters of different color. The letters which appear minimum raised are. Okay. So again, this is apparent depth concept. So they asked which will appear minimum raised. So minimum raised means for it apparent depth. See, this is the glass and here are the markings. So minimum raised means this should be minimum. For this object, this may be apparent depth and this will be real depth. So minimum raised means this. That is dr minus dA should be minimum. And we know dr minus dA is dr by mu. So it is dr into 1 minus 1 by mu. This is the raise. So this raise should be minimum. So this should be minimum. For this to be minimum, this should be maximum. For this to be maximum, this should be minimum. So mu should be minimum for this. So for what value mu will be minimum? We know refractive index is C by V and V is equal to F lambda. So if this has to be minimum, lambda has to be maximum. And in Vibguer we know lambda is maximum for red. That is red. Then 16th problem. How to solve 16th problem. A cross section of a glass prism has the form of an isosceles triangle. One of the refracting surfaces is silvered. Okay, this is isosceles triangle, and one of the refracting surface faces is silvered. Okay, you can take this as silvered. A ray of light falls normally on the other refracting surface. So here it falls normally. Then, after being reflected twice, it emerges through the base of the prism perpendicular to it. The angles of the prism are okay. So here angles of the prism is angle of the angles of the triangle, all the three angles. So it is falling normally. Then two times the reflection is happening, and then it is emerging from the base. So how to solve this? Let's see. So here it is coming normally. This is normal. And suppose here it is hitting at theta angle. And this will also be theta. I is equal to R. And it is hitting here. And here also reflection is happening. Maybe I is greater than IC, then reflection will happen. If reflection happens, then it will go through base. And we know this is 90. They have told this is 90. And suppose this is some other angle, maybe alpha. And this will also be alpha. I is equal to R. Now what we can do? We want these angles, right? If this is theta, maybe I can draw a little bigger. And taken this as theta. And little more bigger. This will be theta. And this is 90. So if this is 90, this is 90. If this is 90, see here, this is normal. So this is 90 minus theta. So this is theta. If this is 90 minus theta, this should be theta. Right? Then here also, this is a normal. Then this is going like this. Actually, it is going normally actually. This is 90 degree actually. And I told this, let us take as alpha. So this is alpha, this is normal. So this is 90 minus alpha. So this should be alpha. Because this is 90. 90 minus alpha. So this should be alpha. So our job is to find this. And this is isosceles triangle. So if this is alpha, this will also be alpha. So basically we have to find theta and alpha. Angle of the prism. So how to find? And now if you see, see what we can do. One equation we can get, that is theta plus 2 alpha is equal to 180. Right? Triangle, angles and the triangle. Another thing is, see here, this is 90 degree and this triangle you see. This angle is 2 theta. This is 90. This angle is 90 minus alpha. So here also theta plus 90 minus alpha r should be 90, right? And 90 cancels. Sorry, 2 theta plus 90 minus alpha should be 90. So 90 cancels. So 2 theta is equal to alpha. So 2 theta is equal to alpha. Alpha is equal to 2 theta. So in this, if you substitute alpha is equal to 2 theta, you get 4 theta, 5 theta. 5 theta is equal to 180. So theta will be 180 by 5. That is 3 is 15, 3 is 36. So if theta is 36, alpha is 72. So it is 72, 72, 36. Right? Alpha, alpha, theta. Then 17th problem. 17th, what will we get? The given lenses are broken into 4 parts and rearranged closely as shown. The initial focal length is f after rearrangement focal length. See in this, when lens is cut like this, focal length will not change because 1 by f is equal to mu 2 1 minus 1 into 1 by r1 minus 1 by r2. And here, in this case, this will be r1 plus r, this will be r2 minus r. So 2 by r we can write just like that, right? Just into 2 by r. So when you cut it like this will not change, this will also not change, r1, r2 will not change. So focal length will not change. But now when you cut it like this, so this has same focal length and this also has same focal length. Now you cut this like this. So it became like this. So here if you see, R1 is R only, but R2 is infinity. So this becomes 1 by R. So 1 by F dash becomes mu 2 1 minus 1 into 1 by R. And mu 2 1 minus 1 into 1 by R is 1 by 2F. So F dash becomes 2F. And similarly for other parts also it will be 2F. So all of them have focal length how much? 2F. So effective focal length will be 1 by F plus 1 by F 4 by focal length of each lens, that is 2F. So it is 2 by F, which is F by 2. Now we'll go for 18th problem. So two plane mirrors are kept parallel at 20 centimeters from each other. A point object O is placed exactly in between them. Calculate distance. So distance between second image is found by two mirrors. So first, okay, if you see this mirror, its first image will be at 10 centimeters, correct? And its first image of this mirror will be also at 10 centimeters. This object is at 10 centimeter, image will be at 10 centimeters. So these are the first images, right? Now second image for this mirror. For this mirror, this will be the object now, image of first mirror. So this image, this object is at 10, 10, 10, 30 centimeter from here. So it will be here at 30 centimeter. And this will be your second image. Right? And for this, what will be second image? This will be the object. Then this is at 10, 10, 10, 30. So from here, 30 centimeter again. So this will be the second image for this. So they have asked distance between second images. So it will be 30 plus 30, 60 plus 20, 80. Then 19th problem. The XZ plane separates the two media A and B of refraction. So it is XZ plane. So if suppose this is there. So this is XZ plane. Then refractive index they have given. and 1 is 1.5. This is 2. So it is coming like this. So this is the error to denser towards the normal, and it bends towards the normal. Z remains constant, but X, you see, X component here it is this much, but in refracted ray X is this much. So X component changes, and because it is in XZ plane, these are the directions of the light unit vectors. Because it is in XZ plane and Y is perpendicular along the normal, so Y component will not change. Here it is like this direction unit vector. For this also this will be like this. So B will be equal to D. But A and B will vary. A and C will vary. So how much it will be? If we see properly diagram, C is less compared to A. So A will be greater than C. By how much amount? A by C will be N. C is, so here we get 2, here we get 3 by 2, that is 1.5. So we get 4 by 3. So A by C will be 4 by 3. B will be equal to B. So this will get cancelled. So 20th. A thin converging lens of focal length f is equal to 25 cm forms the image of an object on a screen placed at a distance of 75 cm from the lens. Now the screen is moved closer to the lens by a distance of 25 cm, distance through which the object has to be shifted. So that its image on the screen is sharp again. So initially if you see what is the object distance, focal length is 25 cm. Screen is at 75 cm. So 1 by f is equal to 1 by v minus 1 by u. 1 by f is this. 1 by v is 75 minus 1 by u. So 1 by u will be 1 by 75 minus 1 by 24, which is minus 75 by 2. This will be your u1. And now screen is moved closer to the lens by 25 centimeters. So nu v is minus 50. Nu v is 50. So 1 by 25 is equal to 1 by 50 minus 1 by u. So 1 by u is equal to 1 by 50 minus 1 by 25. That is 1 by 50 minus 1 by 25 minus 1 by 50. So this is 50 and this is minus 37.5. So how much is the shift? The shift is 50 minus 37 point. That is 5, 9, 2, 1, 12.5. I'll go for the next question. So 23rd, if you check, there is a point. A point object is moving with a speed of the speed v in front of an arrangement of two mirrors as shown in figure. Okay. If the velocity of image in mirror m1 with respect to image in mirror m2 is n v sin theta, we will find n. So how to solve this? If you see this object's image here will be just like this going in a straight only. This plane mirror, its image will be formed here, its image will be formed here when it moves here, when it moves little forward also. Same way it will also move forward, so its image will be here. So if its velocity is like this, its velocity will also be like this only, v. But now you come to image of m1, image due to m1. So image due to m1, if you see, one light ray will come like this, right? The normal will be there, and it will go like this, reflected ray, and it will form image this side, and one ray will come like this, and its image will be formed here, where this distance and this distance will be same. Right. Right. Now if it comes little forward, same thing happens, and its image will be formed somewhere here. Right. So when it comes with velocity v like this, it will also come with velocity v in this direction. Right. Now, suppose this is x-axis, then if this is theta, this will also be theta, corresponding angle, and this is normal here. This is normal. So this is theta. What you can tell here? This is theta. Then this theta, this is 90 minus theta, and this is 90 degree. This is 90 minus theta. This is 90 degree. So this line is straight. So this will be theta, vertically opposite angles. Correct? Then this is theta, and this will be 90 minus theta, and this will be 90 minus theta is equal to r. If this is 90 minus theta, this will be theta. Right? So if you see, the image due to m1 is moving along a line which is making 2 theta angle with x-axis, and image due to m2 is along x-axis. Its velocity is along x-axis. So this is due to m2. It is along x-axis. This is due to m2. Due to m1, the velocity is along. This velocity is like this, and it is 2 theta. It is making angle 2 theta with x-axis. This is due to m1. This is due to m2. Now we want m1's velocity with respect to m2. So how do we get? This will have two components. One will be like this, one will be like this. So if you take uh, relative motion, then it will be this is theta, this is 90 minus 2 theta, sorry, 180 minus 2 theta. This will be V cos 180 minus 2 theta. And it is third quadrant. So it will be V cos 2 theta. Magnitude, if you see, V cos 2 theta. This will be V sin 2 theta. Correct? So now relative velocity they are asking. So in x direction, relative velocity will be V minus V cos 2 theta. Correct? This will be like I cap and this will be like minus I cap. So relative velocity in x direction is this much. And in y direction, relative velocity is V sin 2 theta j cap. This has no component. So now net relative velocity will be root of Vx square plus Vy square, which will come to, you can solve it. This will become root of V, if you take common, you will get V square 1 minus cos 2 theta whole square plus V square sin square 2 theta. This can be expanded. V square plus V square cos square 2 theta minus 2ab minus 2V square cos 2 theta plus V square sin square 2 theta. So this becomes V square. Sin square theta plus cos square theta is 1. So this becomes root of 2V square minus 2V square cos square 2 theta. Right? Then this will not be cos square 2 theta. This will be cos 2 theta minus 2ab, right? Cos 2 theta. So here I can take 2V square common. What I will get? 1 minus cos 2 theta. And we know 1 minus cos 2 theta is 2 sin square theta. So it becomes 2 sin square theta, 2 to 4, root of 4V square sin square theta. So it becomes 2V sin theta. So V sin theta into 2. So N is 2. Then next problem. Diameter of or aperture of a plano convex lens is 6 centimeter and its thickness at the center is 3 centimeter. The image of an object formed is real and twice the size of the object. If the speed of light in the material of the lens is 2 into 10 power 8 per second, the distance where the object is placed from the plano convex lens is. So for lens M is equal to V by U. They have asked U actually. And M is given as 2. That is the real image. So it will be minus 2. Minus 2. V is equal to minus 2U. So we know 1 by F is equal to 1 by V minus 1 by U. So here we can put 1 by minus 2U minus 1 by U. It will become 3 by 2, 2 by 3. 2U by 3 minus 2U by 3 is equal to F. This much will give. But you want U, you don't know F also. So how to get F? For a lens maker's formula, that is 1 by f is equal to 1 by, sorry, mu2 1 minus 1 into 1 by r1 minus 1 by r2. This is plane of convex lens, so r2 I will take infinity, so it will become 1 by r. So how to get mu now? See, they have given speed of light in like in medium. So we know refractive index is c by v. So it becomes 3 into 10 power 8 by 2 into 10 power 8, that is 3 by 2. So refractive index we got. Now how to get r? See, this is diameter of the plane of convex lens. So that is aperture's diameter actually, but we want radius of curvature, right? If this is a lens, if you see it from front, it will look like this. So this 6 centimeter is this radius, but we want this radius of curvature. So radius of curvature formula is r square by 2x, okay? Where x is thickness and small r is this aperture's diameter, radius. So radius is 3 centimeter by 2 into 3. It becomes 3 by 2 again. So this becomes 3 by 2 minus 1, 1 by 2, 1 by 2 into 3 by 2. Sorry, 1 by 2 into, this is by 3 by 2, 2 by 3. So 2 cancels, f is equal to 3. So this becomes 3. Oh, thickness is in mm. Then this becomes 0.3 centimeter, right? Or 3 into 10 power minus 1. This becomes 10 power minus 2. Goes up 10 power minus 1, sorry. Goes up 30 by 2, 15 it will become. So this will be 1 by 15, will be 30. So then in the 15, the u will become minus 45. So 45 means 15 into 3. Answer is 3. Now we will see 25th problem. So a converging length of focal length 15 centimeters. And a converging mirror of focal length 20 centimeters are placed with their principal axis coinciding. Correct? So we can do. The point source S is placed on the principal axis at a distance 12 centimeters. So this is 12 centimeters from lens. It is found that final beam comes parallel to the principal axis. So this should be this is the mirror and this is the lens. This will be mirror's focal length, a focal point. So this will be FM, correct, which is 20 centimeters. This will be for sure, right? So then they are asking, let the separation between the mirror and the lens be 10K. So what is this 10K? So they are asking K. So how to find? See, for the mirror, now image is understood to be here, image distance. But what is object distance? Image of the lens will become object for the mirror. So for the lens, if you see, what you will get? 1 by f is 1 by v minus 1 by u. For the lens, f is 15. Image should be here. Okay, image you will see minus 1 by u. U is 12, minus 12. So 1 by v is equal to 1 by 15 minus 1 by 12. This becomes 12 minus 15 is minus 3. Minus 3 by 15 into 12. 3 ones are 3 fours are 15 fours are 60. So V becomes minus 60. Minus 60 means it is virtual image. This is less than focal length. Hai na? So this is 60. From the lens, it is 60. Right? So it is 60 now. Uh, 60. Now for the lens, sorry, for the mirror. This is 60. So we got as minus 60. Okay? So actually, here the image is formed here and it is going parallel. It means for this lens, this ray should be going through focus, correct? So this is f of the lens actually. So this should be focal length of lens. This is not. This is image distance for this mirror. Right? So this is going through focus, so it is going parallel. So we see now if you apply for mirror formula, 1 by f is equal to 1 by v plus 1 by u. So for the mirror, focal length is, this is concave mirror. So radius of curvature will be negative. Sorry, focal length will be negative. And how much is the focal length? 20 minus 20. 1 by image. Its image distance we don't know. So image distance I'll keep like that only. And its object distance. Its object distance will be how much? For this mirror, this is object. And how much is that distance? 60 plus this focal length is 15, 75. 75 plus this is V. So it will be, if you take this distance as some D, then V will be minus D. And this will be minus of 75 plus D. And if you find D, then 15 plus this D will be 10K. Right? K will get. So now if you solve this, what will you get? Minus 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 cancel. We'll get 75 plus D plus D by 75 plus D into D. Let's go 1 by 20. Now if you solve, you will get D as actually if you see, you will get an equation like this, which will be D square plus 35D minus 1500 is equal to 0. You will get an equation like this, where roots will be 65 and not 65. The roots will be 25 and 60. These two roots are there. 60 minus 25 is 35. Into if you do, you will get 1500. So these are the roots. So one is minus 25, one is plus 60. So D will be either 25 or minus 60. So minus 60 is not possible. So this should be 25. So now the distance is 25 plus 15, that is 40. So K becomes 4. Now we'll go for the next question. An extended object of size 2 mm is placed on principal axis. of converging lens of focal length. The converging lens is there, is kept. Focal length is 10 centimeter. So the SI 2 mm is kept. It is found when the object is placed perpendicular to the principal axis. The image is formed 4 mm inside. So they form an image and its size is 4 mm. The magnification is magnitude is 2. So in size of the image when it is placed along the principal axis. So when it is placed like this, it's 2 mm. The image formed is 4 mm. Sorry, when it is placed along the principal axis, the size of the image is how much? So size of the image how much? Right? So this is called as longitudinal magnification and transverse magnification. Transverse magnification means magnification which is happening in a direction perpendicular to the principal axis, which we generally call as magnification, HI by HO. And that is given to be 2 here, magnitude if you see, right? And this is transverse magnification. Sorry, this is longitudinal magnification. So here, if you see, this is 2 mm compared to centimeters or other dimensions. This is very small. So if you consider this as u, this will be u plus du. And here, the image is suppose formed like this. One will be u, one will be v plus dv. So basically, you have to find du will be 2 mm. You have to find dv. Otherwise, you can use formula 1 by f is 1 by v minus 1 by u. And its image where it is formed, you see. And its image where it is formed, you see. Image distance, object distance will change by. If one is suppose 15, another will be 15 minus 0.2 centimeter, that is 14.8. Correspondingly, you find v, subtract both v values, you will get size of image. But this is simple. It is 1 by f is equal to 1 by v minus 1 by u for a lens. So if you differentiate, what you will get? This will be 0. This will be minus 1 by v square dv. This will be minus 1 by u square. So this goes that side. So dv by v square becomes 1 by u square. Here du. Okay. So dv will be v square by u square into dv. And v by u is m square d. So m is 2, 2 square is 4, 4 into 2 mm, du is 2. So size is 8 mm. So size of the image will be 8 mm. 8 is the answer. So it's over, I think. We'll end it here.